Welcome, everyone. It's wonderful to have you here. Before we get started, would you let us know in the comments where you're tuning in from and the time of day it is for you? I love seeing how this space brings together people from across the globe. A heartfelt thank you as well to all who've subscribed and supported the channel. It helps me know what connects with you, and it helps others discover these calming moments too. And if inspiration strikes, please feel free to leave your ideas for future videos. With that said, let's begin. Chapter 1: Understanding Tree Communication Basics. In the heart of every forest, a remarkable exchange unfolds beneath the surface, a silent symphony played by roots and fungi, intertwined in a complex web of communication. Trees, those towering sentinels of the natural world, possess a rich language that transcends mere whispers of the wind. They communicate in ways that may astonish us, and as we explore these methods, we begin to grasp the intricate relationships that sustain life in the forest. Trees utilize various methods to communicate, each uniquely adapted to their environment. One of the most fascinating forms of communication is through chemical signals. When a tree is under threat from pests or disease, it can release volatile organic compounds into the air. These chemicals serve as distress signals, alerting neighboring trees to prepare their defenses. Imagine a tree standing resolute, its leaves trembling slightly as it sends out a warning into the breeze. Nearby trees, sensing this alarm, might increase their own production of protective compounds, thus fortifying themselves against the impending threat. Another method of communication involves the root systems of trees. Beneath the forest floor lies a hidden world of connections, where roots extend and intertwine, sharing nutrients and information. Trees can exchange vital resources such as water and minerals, ensuring the survival of not only themselves but also their companions. This underground network is often facilitated by mycorrhizal fungi, which form symbiotic relationships with tree roots. The fungi extend their filaments into the soil, reaching beyond the tree's immediate grasp. In return for the sugars produced by the tree through photosynthesis, the fungi provide essential nutrients, creating a mutually beneficial partnership. Have you ever wondered how trees can thrive in harsh conditions? The answer lies in their ability to communicate and cooperate with one another. In forests, trees often engage in a form of altruism, sharing resources with their neighbors, particularly those of the same species. This phenomenon, known as kin selection, allows trees to support their relatives, ensuring the continuation of their shared genetic lineage. The forest thrives not merely as a collection of individual trees, but as a community, interconnected and interdependent. As we delve deeper, we encounter the concept of the wood wide web, a term that captures the essence of this vast underground network. This intricate system of mycorrhizal fungi and tree roots resembles an internet of the natural world, facilitating communication and resource sharing among trees. In this subterranean realm, trees can send messages of distress, share nutrients, and even help foster the growth of seedlings. The wood wide web exemplifies the profound interconnectedness of life within a forest ecosystem. Consider the story of a young sapling struggling for survival in a dense forest. It may find itself overshadowed by larger trees competing for sunlight and nutrients. Yet, through the wood wide web, the surrounding trees can extend their support. They may send extra nutrients through the fungal network, nurturing the sapling and helping it to grow. In this way, the forest becomes a nurturing environment, one that not only supports its strongest members, but also provides a lifeline for the vulnerable. Furthermore, trees can communicate through root exudates, which are substances released into the soil. These exudates can attract beneficial microorganisms, enhancing the health of the soil and creating a richer environment for all. When a tree releases these compounds, it is like sending an invitation to beneficial bacteria and fungi, inviting them to join in a dance of collaboration and growth. This intricate relationship highlights how trees are not solitary beings but active participants in their ecosystem, shaping the very environment in which they thrive. The importance of communication for tree survival cannot be overstated. Trees that can effectively communicate and cooperate are more resilient in the face of challenges. Studies have shown that forests with diverse species and robust communication networks are better able to withstand pests, diseases, and environmental stressors. In this sense, communication fosters not only individual survival, but also the health of the entire ecosystem. As we reflect on these extraordinary communication methods, we can draw parallels to our own interactions. Just as trees share information and resources, we too rely on connections with others to thrive. What if we could learn from the forest, embracing the spirit of collaboration and support? The lessons of the trees remind us that strength often lies in unity, and that our survival is intricately tied to those around us. In the vast expanse of the natural world, trees stand as guardians of wisdom, teaching us about resilience, cooperation, and the profound connections that bind us all. Their ability to communicate, to nurture, and to support one another reveals a depth of intelligence that challenges our understanding of life. As we explore the wonders of tree communication, we are invited to ponder the nature of our own relationships and the impact of collaboration in our lives. The Wood Wide Web is not merely a concept. It is a testament to the ingenuity of nature. It illustrates how life can flourish through interconnectedness, a reminder that we are all part of a larger community. As the trees whisper their secrets to one another, they tell us a story of survival, a narrative woven into the very fabric of the forest. Just as we listen to their stories, we are called to reflect on our own, to recognize the importance of connection in our journey through life. In this intricate web of communication, every tree plays a role, each contributing its unique voice to the symphony of the forest. The next time you find yourself in the presence of towering trees, take a moment to pause and appreciate the unseen world that thrives beneath your feet. Imagine the conversations taking place, the exchanges of life-sustaining nutrients, and the silent support offered amongst the giants. As we continue to explore the depths of tree communication, we will uncover even more extraordinary insights into the life of forests. Each chapter will reveal new layers of understanding, inviting us to appreciate the beauty and complexity of nature's design. The journey into the world of trees is just beginning, and with each step, we become more attuned to the whispers of the woods. In exploring the Wood Wide Web, we begin to appreciate the profound implications of tree communication on forest resilience. This network not only facilitates the exchange of nutrients and information, but also plays a pivotal role in the overall health of the ecosystem. Imagine a vast community of trees, each one uniquely adapted to its environment, yet intricately connected to its neighbors. They form a complex system where the survival of one can significantly influence the well-being of many. One remarkable aspect of this communication is the role of mycorrhizal networks in the process of forest succession. When a disturbance occurs, such as a fire or a storm, the recovery of the ecosystem depends on the ability of trees to communicate and cooperate. In the aftermath of such events, trees can share resources with seedlings, helping to nurture a new generation. The mycorrhizal fungi act as intermediaries, delivering vital nutrients from established trees to young saplings, thus fostering a resilient community that can rebound from adversity. Consider the story of Suzanne Simard, a pioneering ecologist who has devoted her life to studying tree communication. Her research has unveiled the complexities of these underground networks, revealing how trees can recognize their kin and preferentially support them. Simard eloquently stated, "The forest is not a collection of individual trees, but a community of interconnected lives." Her work has transformed our understanding of forest dynamics, illustrating the importance of cooperation in the natural world. Imagine walking through a forest after a rainstorm, the air thick with the scent of damp earth and the sound of droplets falling from leaves. Beneath the surface, a vibrant world is alive, where trees communicate their needs and share resources in a delicate balance. This hidden life reveals the intricate relationships that bind them together. reminding us that survival is often a collective endeavor. In addition to mycorrhizal networks, trees also engage in what can be described as a chemical dialogue. When under stress, trees can release specific compounds that serve to warn neighboring trees of potential danger. These chemical signals can alert others to pests or pathogens, prompting a preemptive response. This phenomenon raises fascinating questions. How do trees decipher these signals? What does it mean to be attuned to the needs of others in such a silent yet powerful way? Picture a grove of trees, standing tall and serene, yet sharing an invisible language through the air. In this way, trees exemplify a sense of community that extends beyond mere survival. It's about thriving together in the face of challenges. Their ability to communicate not only protects individual trees, but strengthens the entire forest ecosystem. As we delve further into the world of tree communication, we uncover another captivating aspect: the role of sound. Recent studies have suggested that trees may also utilize vibrations and sound waves to communicate with one another. Under certain conditions, trees can transmit low-frequency sounds through the soil, potentially alerting their neighbors to distress. This adds an entirely new dimension to our understanding of forest communication, as it suggests that trees might possess a complex awareness of their surroundings. Imagine standing quietly in a forest, closing your eyes and listening intently. Can you hear the subtle vibrations of life all around you? It is a gentle reminder that every being in the forest, from the smallest mushroom to the tallest tree, is engaged in a continuous exchange of information. This symphony of sound and silence weaves a rich narrative, one that underscores the interconnectedness of all living things. As we consider the implications of these communication methods, we must also reflect on the impact of human activity on these delicate networks. Deforestation, urban development, and climate change threaten the very fabric of forest ecosystems. When trees are removed or ecosystems are disrupted, the intricate communication channels that have evolved over millennia are severed. This loss not only affects the trees, but ripples through the entire community, leading to decreased biodiversity and greater vulnerability to diseases and pests. Yet, amidst these challenges, there are stories of resilience. Conservation efforts and reforestation projects aim to restore these vital networks, allowing forests to heal and thrive once more. Imagine the joy of planting a tree, knowing that you are contributing to a larger narrative of growth and connection. Each sapling holds the potential to become a part of a greater community, fostering relationships that will endure for generations. As we ponder the significance of tree communication, let us also embrace the lessons they impart. Trees teach us about patience, cooperation, and the importance of nurturing connections. Just as they extend their roots to support one another, we too can reach out to those around us, cultivating relationships that enrich our lives and the lives of others. In the quiet moments spent among the trees, we can find solace and wisdom. Each tree stands as a testament to the power of communication, reminding us that we are all part of a larger story. As we continue to explore the wonders of tree communication, we are invited to reflect on our own connections and the ways in which we can contribute to the collective well-being of our communities. As we step forward in our journey through the realm of trees, we will uncover even more astonishing insights and stories that await us. The forest, with its myriad of voices, invites us to listen, to learn, and to marvel at the intricate design of life that surrounds us. The adventure of discovery has only just begun, and with each revelation, we deepen our appreciation for the remarkable world of trees and their silent yet powerful communication. Chapter 2. The Role of Roots in Tree Communication. Beneath the gentle embrace of the forest floor, an intricate world thrives, a realm where roots communicate and interact in ways that extend beyond our understanding. As we focus on the roots of trees, we uncover a hidden network, a web of connections that plays a pivotal role in the life of the forest. Roots are not merely anchors, they are conduits of information and vitality, interacting with one another in a silent yet profound manner. Imagine a vast underground landscape where roots intertwine, forming a complex network akin to a bustling city. This city is alive with activity, as roots send chemical signals through the soil, establishing a dialogue with neighboring trees. This communication is vital for survival. When one tree faces a challenge, be it from disease or competition, it can send out signals to its neighbors, warning them of potential threats. The forest, in its wisdom, operates as a community rather than a collection of isolated individuals. One of the most fascinating aspects of this underground communication is the phenomenon of root exudates. These are substances released by roots into the soil, laden with chemical signals that convey information about the tree's health and needs. Through these exudates, trees can share nutrients, a vital resource that often determines their growth and well-being. Imagine a tree, its roots spreading through the earth, releasing a cocktail of sugars, amino acids, and other compounds. These substances serve a dual purpose. They nourish beneficial microbes and fungi in the soil, while also signaling to nearby roots about what nutrients are available. Scientific inquiry into root exudates has revealed the remarkable ways in which trees collaborate. For instance, studies show that when trees are subjected to stress, such as drought or nutrient deficiency, they alter the composition of their root exudates. This adjustment allows them to communicate their needs more effectively, prompting neighboring trees to enhance their own nutrient uptake or adjust their growth patterns. This exchange is not merely altruism. It is a survival strategy that enhances the resilience of the entire forest ecosystem. The impact of root systems on tree health and growth cannot be overstated. A tree's root network is essential in anchoring it firmly in the soil, but it does so much more. Roots are responsible for absorbing water and nutrients, and their extensive networks allow for efficient resource sharing among trees. In many species, roots can reach far beyond the tree's canopy, tapping into hidden reserves of moisture and nutrients that are otherwise inaccessible. Consider a towering oak, its branches stretching skyward while its roots delve deep into the earth. This majestic tree is not alone. It is part of a larger community of trees working in concert to optimize their chances of survival. As the oak's roots intertwine with those of neighboring trees, they create a shared space where resources can be pooled. This collaboration can be particularly beneficial in times of drought, where a tree's ability to access deeper, more stable groundwater can mean the difference between thriving and merely surviving. Remarkably, trees also display a level of sophistication in their interactions. Research has shown that certain species of trees can distinguish between kin and non-kin based on their root interactions. When faced with competition, trees may alter their growth strategies, choosing to invest more in their root systems when competing with unrelated trees. This ability to recognize family groups suggests a deeper level of social organization among trees, one that promotes cooperation and mutual aid. In the depths of this underground world, the role of mycorrhizal fungi emerges as a crucial player in tree communication. These fungi form symbiotic relationships with tree roots, extending their own networks to connect multiple trees. Through mycorrhizal networks, trees can exchange not only nutrients but also information. This interconnectedness allows trees to support one another in times of stress, enhancing the overall resilience of the forest. Imagine the fungi as the internet of the forest, facilitating communication and resource sharing among trees. When one tree is under attack, it can send distress signals through the mycorrhizal network, alerting others to bolster their defenses. This cooperation is not limited to trees of the same species. Different species can also benefit from these connections, creating a diverse and resilient ecosystem. As we contemplate the role of roots in tree communication, we are drawn to the idea that these interactions echo the principles of community and cooperation found in human societies. Trees, through their roots and the networks they form, showcase the power of interconnectedness. It raises the question, what can we learn from the silent exchanges happening beneath our feet? The health of a tree is inextricably linked to the health of its root system. A well-established root network enhances a tree's ability to absorb water and nutrients, leading to vigorous growth and vitality. Conversely, a compromised root system can lead to a cascade of issues, affecting the tree's overall health. This delicate balance underscores the importance of understanding tree roots not just as physical extensions of the tree, but as vital components of a larger ecosystem. As we observe trees in their natural habitats, we might consider the profound impact of their root systems. When we walk through a forest, we often marvel at the grandeur of the towering trees, their leaves rustling in the wind. Yet beneath the surface lies a bustling community, one that thrives on cooperation and communication. The roots are the unsung heroes, silently working to ensure that each tree can stand tall and flourish. The dynamic relationships among trees, facilitated by their root systems, remind us of the importance of community in our own lives. Just as trees share nutrients and information, we too can benefit from the support and connections we forge with one another. In essence, the roots of trees are not merely structures for stability. They are alive with communication, sharing the vital resources that sustain life. As we continue to explore the wonders of tree communication, we will uncover the myriad ways in which these remarkable organisms connect, support, and thrive together in the shared tapestry of the forest. The connection between tree roots and their health extends to their interactions with the surrounding soil. The soil itself is not merely a medium for support. It is a vibrant ecosystem teeming with life. Microorganisms such as bacteria and fungi play critical roles in this underground community, aiding trees in nutrient absorption and fostering a thriving environment. Through root exudates, trees invite these beneficial microbes into their fold. The relationship is symbiotic. The tree provides sugars and organic compounds, while the microbes, in turn, unlock nutrients, making them more accessible to the roots. Imagine the microscopic world of bacteria working in harmony with tree roots, breaking down complex compounds into simpler forms that trees can absorb. This ongoing interaction exemplifies the interconnectedness of life in the forest. In this bustling environment, trees communicate not just with each other, but with the myriad organisms that share their space. The soil becomes a medium of dialogue, a place where roots and microbes exchange messages vital for survival. As we ponder the impact of root systems on tree health, we must consider the concept of root depth and spread. Different species have evolved distinct root architectures suited to their environments. For instance, some trees have deep taproots, reaching down to access water stored far below the surface. Others develop wide-ranging lateral roots, creating a broad network that maximizes their access to nutrients in the upper soil layers. This diversity in root structure is fascinating. It reflects the adaptability of trees to their specific habitats. Have you ever thought about how a tree's ability to thrive in diverse environments is a testament to its evolutionary journey? Trees that inhabit arid regions, for example, have developed root strategies that allow them to endure long periods without water, showcasing their resilience. These adaptations are not merely survival mechanisms. They are a testament to the intricate relationships formed between trees and their habitats over millennia. In the realm of competition, root systems play a crucial role in determining the fate of individual trees. Trees often compete for limited resources, and their root interactions can dictate their growth success. Through allelopathy, some trees release chemicals through their roots that inhibit the growth of neighboring plants. This strategy ensures that they have access to the nutrients and space they require to flourish. However, the balance of competition and cooperation is delicate. In many cases, trees that engage in a more collaborative approach, sharing resources through their root systems, find greater success in maintaining a healthy community. Consider the wisdom of nature as trees navigate these challenges. In some forests, older trees, often referred to as mother trees, play a significant role in nurturing the younger generation. Through their extensive root systems, these older trees can share resources, providing support to saplings struggling to thrive. This nurturing behavior creates a legacy of growth and resilience, ensuring that the forest continues to flourish. The interactions among trees extend beyond their immediate neighbors. In a broader ecological context, root systems influence soil health and structure, impacting the entire forest ecosystem. Healthy roots contribute to soil stability, preventing erosion and facilitating water retention. This, in turn, creates a favorable environment for other plant species to thrive, promoting biodiversity. Trees are not isolated entities. They are integral components of a larger ecological network, influencing and being influenced by their surroundings. A deeper understanding of tree communication through root systems invites us to reflect on the lessons that can be drawn from their interactions. In a world often driven by competition, trees remind us of the power of cooperation and community. They demonstrate that strength lies not only in individual resilience, but also in the bonds forged through shared experiences and mutual support. As we continue to explore the realm of tree communication, we can appreciate the elegance of their interactions. The underground world of roots is a testament to the complexity and beauty of nature, where each tree plays a vital role in the health and vitality of the forest. The more we learn about these connections, the more we are inspired to foster similar bonds in our own lives, recognizing the importance of community in nurturing our own growth and resilience. Thus, we find ourselves at the intersection of science and wonder, where the study of tree roots unveils a rich narrative of collaboration and communication. With every revelation, we uncover more about the remarkable lives of these towering beings and the hidden world beneath our feet. As we delve further into the mysteries of tree communication, we will continue to uncover the intricate ways in which these magnificent organisms thrive together, weaving a story that transcends the individual, echoing the harmonious symphony of life itself. Chapter 3. Fungi, the connective tissue of trees. Imagine stepping into a serene forest, where the air is thick with the scent of damp earth and the soft rustling of leaves above. Beneath this tranquil surface, an extraordinary partnership unfolds between trees and fungi, forming a bond so deep that it can be likened to the connective tissue of the forest itself. Mycorrhizal fungi, those enigmatic organisms, play a crucial role in this relationship, serving as the bridge between trees and the soil, facilitating a symbiotic exchange that nurtures life. Mycorrhizal fungi attach themselves to the roots of trees, enveloping them in a delicate embrace. This partnership enhances the tree's ability to absorb water and nutrients from the soil, while the fungi, in turn, gain access to the carbohydrates produced by the tree through photosynthesis. It is a beautiful equilibrium where both parties thrive and support each other's existence. As mycologist Paul Stamets eloquently stated, fungi are the great recyclers of the planet. This recycling process begins as mycorrhizal networks extend their filaments, known as hyphae, into the surrounding soil. These hyphae reach far beyond the tree's roots, exploring a vast expanse and unlocking nutrients that would otherwise remain inaccessible. Consider the role of phosphorus, an essential nutrient for plant growth. Mycorrhizal fungi have a remarkable ability to extract this mineral from the soil, transforming it into a form that trees can readily use. It is as if the fungi serve as diligent miners, tirelessly working to unearth precious resources buried deep within the earth. In return for this bounty, trees offer sugars that fuel the fungi's growth, creating a cycle of generosity and mutual benefit. The collaboration between trees and fungi is not merely limited to nutrient exchange. These mycorrhizal networks act as a communication channel, allowing trees to share vital information. Imagine a tree standing tall and resilient, sensing a decline in its neighboring companion. Through the mycorrhizal network, the tree can transmit chemical signals to alert its ally of potential threats, such as a pathogen lurking nearby or the onset of drought. This form of communication adds another layer of depth to the already intricate web of life in the forest. Fungi do not only connect individual trees, they weave a larger tapestry of interactions among diverse species. This phenomenon is often referred to as the wood wide web, a term that captures the essence of these underground networks. Within this web, trees can also exchange nutrients with one another, fostering a sense of community within the forest. It is a profound realization that a tree may sustain another, even one of a different species, highlighting the interconnectedness of life. As we delve deeper into the wonders of these mycorrhizal networks, one cannot help but marvel at the sheer scale of their reach. Studies have shown that a single mycorrhizal fungus can connect multiple trees, creating a vast network that spans entire forests. Imagine this interconnectedness as a living organism, where trees become not just solitary beings but integral parts of a larger community. In this thriving ecosystem, the role of fungi extends beyond mere nutrient exchange. They are also vital in facilitating tree communication, allowing trees to share their experiences and challenges. When one tree experiences stress, such as an attack from pests or changes in environmental conditions, it can send distress signals through the mycorrhizal network. Nearby trees can perceive these signals and respond accordingly, perhaps by bolstering their own defenses or adjusting their nutrient uptake. It is fascinating to think about the implications of such communication. Trees are not passive entities. They exhibit a form of social behavior that can influence the survival of the entire forest. This interconnectedness creates a robust community capable of withstanding challenges together, reinforcing the idea that strength lies in unity. One remarkable example of this can be found in the work of forest ecologist Suzanne Simard, who has spent years studying the relationships between trees and fungi. She discovered that older trees, often referred to as mother trees, play a pivotal role in these networks. Through their extensive mycorrhizal connections, they can nurture younger saplings, sharing resources and information that foster their growth. This nurturing behavior is a testament to the wisdom of the forest, where life perpetuates through cooperation and care. Imagine walking through a forest, surrounded by towering trees, each one a part of a rich, interwoven community. The air is thick with the scent of life and decay, a reminder of the cycles that govern this world. As you pause to take in the beauty around you, consider the unseen world thriving beneath your feet. The mycorrhizal fungi, with their delicate filaments, are the unseen architects of this ecosystem, shaping the very fabric of the forest. Fungi also play a significant role in the health of the soil itself. As they break down organic matter, they contribute to the formation of humus, the dark, nutrient-rich component of soil. This process not only enriches the soil, but also enhances its structure, allowing for better water retention and aeration. It is a delicate dance of decomposition and regeneration, where fungi transform fallen leaves, rotting wood, and other organic materials into the very essence of life. Consider the role of fungi in promoting biodiversity within the forest. By facilitating nutrient exchange and communication among diverse plant species, they help maintain a balanced ecosystem. This balance is crucial for the survival of countless organisms, from insects to mammals, all of which depend on the health of the forest for their sustenance. The intricate relationships fostered by fungi create an environment where life can flourish in myriad forms. As we reflect on the role of fungi in the grand narrative of the forest, it is essential to recognize that these remarkable organisms are not merely passive participants in the ecosystem. They are active players, shaping the landscape and influencing the lives of the trees and other inhabitants. Through their mycorrhizal networks, fungi facilitate a complex web of interactions that sustain life, demonstrating the profound interconnectedness of all living things. Imagine the tranquility of a forest, where every tree, every fungus, and every creature plays a role in the greater symphony of life. The whispers of the wind carry messages of resilience and cooperation, reminding us that we too are part of this intricate web. As we ponder the mysteries of mycorrhizal fungi and their relationships with trees, we begin to understand the delicate balance that sustains our natural world, a balance that is both beautiful and essential. In this ever-evolving landscape, the partnerships between trees and fungi remind us of the importance of connection, not just in nature, but in our lives as well. As we cultivate our relationships with each other and the world around us, we honor the wisdom of the forest, where collaboration and support are the lifeblood of existence. The mycorrhizal networks serve as a powerful metaphor for our interconnectedness, urging us to nurture our bonds and embrace the beauty of cooperation. As we continue our journey through the wonders of the natural world, let us carry with us the lessons learned from the trees and fungi. Their stories of resilience, communication, and support beckon us to reflect on our place within this vast tapestry of life, reminding us that we are all connected in ways we may not yet fully comprehend. As the forest continues to breathe and pulse with life, the role of mycorrhizal fungi becomes even more profound. These remarkable organisms are not merely passive participants in the nutrient exchange, but are active facilitators of a broader ecological dialogue. In this world beneath our feet, fungi not only connect trees to the soil but also to each other, creating a dynamic network that transcends species and individual survival. Imagine a vast underground city where mycorrhizal fungi serve as the highways of communication. Through their extensive hyphal networks, they facilitate nutrient exchange between trees that might otherwise be isolated. This interconnectedness ensures that when one tree is thriving, its surplus can benefit those in need. Picture a towering oak sharing its bounty with a struggling birch nearby, each organism playing its part in a communal effort to sustain life. This cooperative spirit is not limited to nutrient sharing. Mycorrhizal fungi also create a conduit for trees to communicate about threats and challenges. The wisdom of the forest is not just in the exchange of materials, but in the exchange of information. When a tree is under attack, it can send out signals through these fungal networks, alerting its neighbors to raise their defenses. It is as if the forest itself whispers warnings from one end to the other, creating a chorus of preparedness that echoes through the roots and soil. The implications of such communication are staggering. Forests are not merely collections of individual organisms, they are complex communities that thrive on cooperation. This phenomenon raises questions about how we perceive trees and their relationships. Are they solitary beings, or do they function as part of a larger organism, deeply intertwined with their neighbors? The answer lies in the intricate web of life that mycorrhizal fungi create. Consider the fascinating research conducted by forest ecologist Suzanne Simard, who has been a pioneer in understanding these relationships. Her studies have shown that trees can send distress signals through the mycorrhizal networks, allowing them to respond to threats more effectively. She describes these connections as a mother tree phenomenon, where older trees act as central hubs, nurturing younger saplings and guiding their growth through the sharing of resources. This nurturing aspect exemplifies the interconnectedness of life in the forest, where each tree is not just focused on its survival, but is also invested in the well-being of its community. Imagine walking through this thriving ecosystem, where every rustle of leaves carries a message, where every root intertwines with another in a shared purpose. The forest is alive with stories of resilience, cooperation, and survival, all facilitated by the mycorrhizal networks that weave through the soil like veins in a living being. Fungi also play an essential role in maintaining soil health, acting as nature's recyclers. As they break down organic matter, they contribute to the formation of healthy soil, rich in nutrients that support a diverse array of life. This decomposition process is not merely an end, but a beginning, as fungi transform fallen leaves and decaying wood into the building blocks of new life. The humus they create enriches the soil, enhancing its structure and capacity to retain moisture, ultimately benefiting all the organisms that call the forest home. In this delicate ecosystem, the relationship between fungi and trees extends beyond individual species. It promotes biodiversity, ensuring that various organisms can coexist and thrive. The nutrient-sharing networks foster resilience, allowing the forest to bounce back from disturbances, whether they come from natural events or human intervention. As we reflect on the myriad roles of fungi, we can envision a forest that pulses with life, where trees communicate their needs and support one another through intricate networks. The fungi beneath our feet facilitate these connections, serving as the lifeblood of the ecosystem. Let us think about the implications of this knowledge. What if we could apply these lessons of interconnectedness to our own lives? Just as trees rely on their fungal partners for support and sustenance, we too can benefit from nurturing our relationships, fostering a sense of community that echoes the wisdom of the forest. In this gentle embrace of nature, we find a reminder that life thrives on connection, whether it be through mycorrhizal networks or the bonds we forge with one another. The forest, with its towering trees and hidden fungi, teaches us that cooperation and collaboration are essential for survival, a lesson that resonates deeply in our own world. As we continue to explore the wonders of this natural realm, we are invited to pause and reflect on the connections that enrich our lives. The mycorrhizal networks beneath our feet serve as a powerful metaphor, urging us to recognize the strength found in unity and the beauty woven into the fabric of existence. Chapter 4. Chemical Signals, Trees Talking Through Chemicals. Amidst the towering trunks and rustling leaves, a silent conversation unfolds, a dialogue woven through the very air we breathe. Trees, those steadfast giants of the forest, engage in a sophisticated form of communication using chemical signals, a language that resonates with both urgency and grace. The types of chemical signals trees release are as varied as the species themselves, each adapted to their unique environments and challenges. Volatile organic compounds, or VOCs, represent one of the most intriguing aspects of this chemical dialogue. When trees encounter stress, be it from disease, pests, or environmental changes, they respond by emitting these compounds into the atmosphere. Imagine a tree, its branches swaying gently, exhaling a fragrant warning that dances on the breeze. This release is not merely a reaction. It is a call to arms, a signal that ripples through the forest, prompting neighboring trees to bolster their own defenses. Consider the sweet scent of pine or the sharp tang of a resin, a tree's natural response to an invading insect. This aromatic tree, perhaps a mighty pine, releases compounds that can deter pests or even attract predators of those pests, creating a dynamic interplay of life and death among the foliage. The scent is a warning, a herald of danger, as trees rally together in a protective embrace. But how do trees know when to send out these signals? The answer lies in the very essence of their existence, their ability to perceive their environment. Trees possess a remarkable sensitivity to changes in their surroundings. When a tree is wounded, for instance, it may release a cocktail of chemicals to signal distress. This is not a solitary act. It is a collective response where trees share information through the air. As one tree cries out in alarm, others listen and prepare. In 1983, research unveiled the profound effects of these chemical signals, illustrating how trees communicate through volatile organic compounds. These compounds can travel considerable distances, allowing trees to alert even those far removed from the source of danger. Imagine the wind carrying a whisper of caution across the expanse of the forest, a ripple of awareness that cascades from one tree to another. One fascinating case involved a study of acacia trees in Africa. When herbivores like giraffes begin to munch on their leaves, the acacia releases a blend of VOCs that not only alerts neighboring acacia trees, but also triggers them to produce toxins in their leaves. These chemicals serve as a deterrent, transforming the once tender foliage into something less palatable. What if we consider this response as a form of communal defense? It is as if the trees form a network of allies, standing together against a common foe. Another captivating aspect of tree communication through chemicals is the role of stress-induced compounds in shaping the forest ecosystem. When trees are under threat, they may also release signals that encourage beneficial organisms to rally to their aid. This can include the attraction of predatory insects that feast on the pests causing the harm. It is a remarkable example of ecological cooperation, where trees, insects, and even fungi join forces to combat adversity. The process of tree communication is not confined to distress signals alone. Trees also release chemicals to convey a sense of well-being, promoting growth and vitality within the forest community. This broader spectrum of chemical signals creates a rich tapestry of interactions that foster harmony in the natural world. Imagine wandering through a forest where the air is thick with the scent of blooming flowers and verdant greenery. Here, trees communicate not only through distress but also by sharing their health and vitality. They emit chemicals that encourage the growth of surrounding plants, enhancing biodiversity and nurturing a thriving ecosystem. This intricate communication network is essential for the survival of the forest, ensuring that trees support one another in their quest for sunlight, water, and nutrients. As we explore deeper into the world of tree communication, we encounter the phenomenon of talking trees, a term that evokes a sense of wonder. Trees are not solitary beings. They are part of an intricate web of life, relying on one another to thrive. The very act of communicating through chemicals is a testament to their interconnectedness. In the realm of chemical signals, we also find fascinating examples of trees responding to environmental stressors beyond immediate physical threats. In a changing climate, trees are faced with challenges such as drought, temperature fluctuations, and shifting soil conditions. Their ability to communicate these stresses chemically is vital for their survival. When a tree experiences drought, it may release specific compounds that prompt neighboring trees to adjust their water usage. This subtle exchange of information can lead to a synchronized response, where trees collectively conserve water and adapt to the changing conditions. Imagine a forest, once vibrant and lush, now transforming into a more resilient community, each tree adjusting its resources based on the signals it receives from its neighbors. The remarkable capacity for trees to respond to danger and stress through chemical signals is not limited to their individual survival. It also influences the broader ecosystem, affecting the organisms that inhabit the forest. The release of these compounds can attract beneficial insects, while simultaneously deterring harmful ones. This intricate balance fosters a thriving habitat, where every living being plays a crucial role. In this chemical communication network, there is a fascinating story about the interactions between trees and the fungi that connect them. Mycorrhizal fungi, as we have previously explored, act as a bridge between trees and the soil. When trees release chemical signals, these fungi respond by facilitating nutrient exchange and enhancing communication among trees. This partnership exemplifies the beauty of interconnectedness in the forest, where each participant contributes to the collective health of the ecosystem. Consider the story of a giant sequoia standing tall in a lush grove. As it releases chemical signals into the air, it not only communicates with neighboring trees, but also with the mycorrhizal networks beneath the soil. This synergy fosters a sense of community, creating a resilient network that thrives against adversity. The chemical signals trees emit extend beyond their immediate surroundings, influencing the very fabric of the forest. Imagine a world where the air is rich with the scent of life, where trees communicate their needs and desires through a complex web of chemicals that resonate with all forms of life. This world is not merely a dream. It is the reality of the forest, where every tree plays a part in the grand orchestra of existence. As we ponder these intricate relationships, we find ourselves drawn to the wisdom of nature. Trees, with their ability to communicate through chemical signals, challenge our understanding of intelligence and awareness in the natural world. Each tree, in its silent resolve, stands not as an isolated entity, but as part of a living community, where every whisper of the wind carries a story, and every scent released into the air invites others to listen and respond. In the heart of every forest, the air is alive with the essence of these chemical communications, a reminder that even in the quietest moments, life is bustling with activity. Trees are not just sentinels of the land, they are the guardians of a profound narrative that unfolds in whispers and scents, a story of resilience, cooperation, and life itself. Each chemical signal released is a thread woven into the rich fabric of the forest, connecting trees to one another and to the broader web of life. As we continue to explore this realm of chemical communication, we invite you to imagine the vibrant world of trees, alive with the sounds of nature and the sense of life, where every tree plays its part in the symphony of existence. The delicate balance of this ecosystem is a testament to the resilience and interconnectedness of all living beings. In this forest, the act of communication is not merely a survival tactic. It is a celebration of life, a reminder of our shared connection to the natural world. The communication between trees is an intricate dance of chemistry, revealing the depth of their social networks. As we immerse ourselves in this world, we begin to uncover how trees respond not only to immediate threats, but also to the broader environmental challenges they face. When trees are under attack, they often release a variety of chemical signals to communicate their distress. However, this response goes beyond simple alarm. It reflects a complex understanding of their environment and the interconnectedness of life that thrives around them. Trees are capable of recognizing the specific type of threat they face, whether from pests, diseases, or harsh weather conditions. For instance, when trees experience physical damage from herbivores, they may emit a distinct blend of chemical signals that not only warn their neighbors but also trigger the production of specific defensive compounds. These responses can include the synthesis of tannins, which serve to deter further feeding. Imagine walking through a forest and catching a whiff of a sharp, resinous aroma. This scent signals that the trees are under siege, and it warns nearby flora to brace for potential threats. This remarkable ability to distinguish between various dangers is exemplified in the case of certain species of willows. When attacked by caterpillars, these trees can recognize the specific chemical cues released by the herbivores. In response, they produce a unique set of volatile organic compounds tailored to repel those specific pests. This precise communication showcases the sophisticated level of awareness trees possess, allowing them to mount targeted defenses and protect not only themselves, but also their surrounding community. In times of drought, trees exhibit yet another layer of chemical communication. The stress of limited water availability can lead to a release of signals that inform other trees to conserve resources. Picture a parched forest, where the leaves flutter gently in the wind, carrying messages of caution. As one tree senses the dryness of the soil, it shares this knowledge through its vapors, prompting neighboring trees to adjust their water uptake in a collective response to the looming scarcity. This form of cooperation is not merely passive. It highlights the remarkable adaptability of trees in the face of environmental stressors. In a world where climate change is altering the landscape, this chemical dialogue becomes increasingly vital. Trees that can effectively communicate stress and adjust their strategies not only enhance their survival, but also contribute to the resilience of the entire forest ecosystem. The relationship between trees and mycorrhizal fungi plays a crucial role in this chemical communication. These fungal networks, which link the roots of various trees, act as a conduit for the transmission of chemical signals. When a tree releases distress signals, the fungi can relay this information to other trees in the network, amplifying the communal response to threats. Imagine the underground pathways bustling with activity, where mycorrhizal fungi carry messages from one tree to another, facilitating a collective response to danger. In the realm of tree communication, volatile organic compounds serve as both a warning and a beacon. These compounds can travel vast distances, carried by the wind to alert distant trees of impending threats. This phenomenon was beautifully illustrated in a study involving birch trees, which demonstrated that when exposed to herbivory, they would emit specific chemicals that not only warn nearby birches but even those farther away. By releasing these signals into the atmosphere, trees foster a sense of community that transcends individual survival. This intricate web of chemical communication raises a profound question. What does it mean to exist as part of a community? Trees, in their silent resilience, reveal the importance of cooperation and interdependence. Their ability to share information fosters a sense of unity, an understanding that each member of the forest contributes to the greater good. As we delve deeper into the world of tree communication, we encounter the fascinating phenomenon of allelopathy, where trees release specific chemicals that influence the growth and behavior of neighboring plants. This mechanism can inhibit competition by discouraging the growth of certain species, allowing trees to secure resources more effectively. Yet, it can also encourage the growth of other plants that complement their own needs. Imagine a forest where the scent of certain trees permeates the air, subtly guiding the growth of nearby flora. This chemical orchestration is a testament to the trees' awareness of their surroundings, demonstrating a nuanced understanding of how to thrive together. Through this lens of communication, we see the forest not as a collection of isolated individuals, but as a cohesive entity, where every tree plays a vital role in maintaining the balance of life. As we continue to explore the depths of this chemical dialogue, we uncover the wisdom embedded within the silent exchanges that occur each day, an ongoing narrative of survival, support, and interconnectedness that resonates throughout the age-old trees standing watch over the forest. In the midst of this vibrant ecosystem, we find ourselves drawn to the notion of resilience. Trees, through their chemical signals, exhibit an extraordinary capacity to adapt and thrive in the face of adversity. This resilience extends not only to individual trees, but to the entire forest community, where the collective strength lies in shared understanding and cooperation. As we reflect on the remarkable stories of tree communication, we begin to appreciate the intricate balance of life that unfolds within the forest. The air, rich with the scent of life and the whispers of chemical signals, serves as a reminder of the hidden dialogues that shape our natural world. In this realm, trees are not mere objects of beauty. They are active participants, engaged in a continuous conversation that transcends the boundaries of species and individual existence. As we stand among these magnificent beings, let us embrace the lessons they impart of cooperation, resilience, and the profound interconnectedness that binds us all in this intricate web of life. The trees, in their silent wisdom, beckon us to listen, to observe, and to honor the delicate balance of existence that thrives in the heart of the forest. Chapter 5. Social Networks Among Trees, Cooperation and Competition. In the heart of the forest, where sunlight filters through the canopy and dapples the forest floor, trees engage in a delicate balance of cooperation and competition. This intricate interplay shapes the very fabric of their communities, revealing a complex social structure that rivals our own. The towering giants, often perceived as solitary figures, are in fact engaged in a sophisticated network of relationships, where each tree plays a vital role in the communal ecosystem. Imagine standing amidst a grove of trees, each one a steadfast sentinel, standing shoulder to shoulder, their roots intertwining beneath the surface. Here, cooperation flourishes, even as competition lurks in the shadows. Trees compete for sunlight, water, and nutrients, yet they also support one another in remarkable ways, showcasing an astounding capacity for altruism. This is not mere survival. It is an exquisite dance of life, a testament to the interconnectedness of all living things. One striking example of altruistic behavior can be observed in the way trees share resources. When a tree is struggling, perhaps due to drought or disease, it can draw upon the support of its neighbors. Through their roots, trees can exchange vital nutrients such as nitrogen and phosphorus, allowing those in need to survive and thrive. It is as if the trees have formed a benevolent society, where the health of one contributes to the vitality of the whole. This sharing is not random. Trees often prioritize those with which they share genetic ties, reinforcing the bonds of kinship that permeate the forest. Consider the intricate communication that takes place beneath the soil. The mycorrhizal networks, discussed in our previous exploration of fungi as the forest's connective tissue, play an essential role in this altruistic exchange. These fungal networks serve as conduits, linking the roots of different trees, facilitating the transfer of nutrients and information. Imagine a conversation flowing through these networks, where one struggling tree sends out an urgent plea for help, and nearby trees respond, offering sustenance to restore balance. The forest, in its wisdom, operates not as a collection of individuals, but as a cohesive community. Yet, this cooperation does not come without a cost, as competition remains a constant presence in the forest. Trees must vie for access to sunlight, and the tallest among them often dominate. This competition can lead to remarkable adaptations, as some trees grow taller and broader to capture more light, while others develop deeper root systems to access water from the soil. The struggle for existence drives innovation, shaping the diverse forms we see in the forest today. How do trees navigate this complex interplay of cooperation and competition? One might imagine a symbiotic relationship where each tree weighs its needs against those of its neighbors. Research shows that trees often assess the health of nearby individuals, choosing to assist those that are closely related or in need. This prioritization reflects an understanding that supporting kin ultimately enhances the survival of their shared lineage. It is a strategy rooted in evolution, where the survival of the fittest includes not just competition, but also compassionate collaboration. Reflect on the words of the renowned biologist Richard Dawkins, who said, "We are survival machines, robot vehicles blindly programmed to preserve the selfish molecules known as genes." In the forest, trees embody this sentiment. While they compete for resources, they also recognize the value of working together. By aiding one another, they enhance their collective chances of survival, ensuring that the forest remains a thriving habitat for generations to come. In these communities, trees exhibit fascinating behaviors that further illuminate their altruism. For instance, some species release chemical signals into the air when they are under threat. These volatile organic compounds act as alerts to neighboring trees, prompting them to bolster their defenses before the danger arrives. It is a preemptive strike, a cooperative gesture that embodies the spirit of the forest. Imagine a tree, its leaves rustling in the breeze, sending out invisible warnings, while its neighbors prepare for the onslaught of pests or disease. This anticipatory communication is a profound example of the interconnectedness that defines forest life. Altruistic behavior among trees can also be observed in the way they assist their offspring. Many trees provide shade and nutrients to their young saplings, ensuring that the next generation has a better chance of thriving. This nurturing extends beyond the immediate family, as established trees often support seedlings in their vicinity. Picture a young tree struggling to reach the sunlight, sheltered beneath the expansive branches of its elder. The elder tree's wisdom is evident, as it sacrifices some of its own resources to ensure the continuation of life. Competition, however, continues to play a pivotal role in shaping the dynamics of these tree communities. The fight for sunlight can lead to fascinating strategies among species. For instance, some trees exhibit a phenomenon known as shade tolerance, enabling them to thrive in lower light conditions. These trees have adapted, growing slower but with a greater capacity to make the most of limited resources. In contrast, fast-growing species may shoot skyward, quickly overshadowing their neighbors. This relentless pursuit of light creates a dynamic landscape, where the tallest trees reach for the heavens, while the undergrowth flourishes in the dappled light below. The balance of cooperation and competition extends to the relationships trees maintain with other flora and fauna within their ecosystems. Trees not only support their own kind, but they also play a crucial role in the lives of countless other species. They provide habitats for birds, insects, and mammals, creating a rich tapestry of life that thrives in their shade. Imagine a tree, its bark rough and weathered, serving as a home for a myriad of creatures. Each animal, in turn, contributes to the ecosystem, whether by spreading seeds, pollinating flowers, or enriching the soil with their waste. A tree's legacy often transcends its own life, as it nurtures a diverse community that relies on its presence. The roots of these relationships run deep, fostering an environment where cooperation is the norm and competition becomes a catalyst for growth and resilience. This intricate web of interactions not only sustains the forest, but it also enriches our understanding of how life thrives in connection with others. As we observe these relationships, it becomes clear that trees possess an innate wisdom and understanding of their place within the ecosystem. They prioritize communication with related species, forming bonds that enhance their chances of survival. In a world where competition is fierce, trees recognize the importance of kinship, fostering a sense of community that extends beyond mere survival. This interplay of cooperation and competition invites us to reflect on our own connections within our communities. Just as trees thrive in cooperation, so too can we find strength in supporting one another. The forest teaches us that, while competition is a natural part of life, it is through collaboration that we can truly flourish. In this rich landscape of trees, where cooperation and competition intertwine, the forest stands as a testament to the beauty of interconnectedness. Each tree, with its unique story, contributes to a greater narrative, a living testament to the enduring power of life that persists in harmony, even amidst challenges. The forest is a sanctuary of wisdom, where nature's lessons beckon us to explore the depths of our own relationships, fostering a sense of unity and understanding, just as the trees do. As these trees thrive together, their interactions extend beyond mere survival. They form alliances that speak to a deeper instinct for community and resilience. The balance of cooperation and competition becomes particularly evident when observing how trees communicate their needs and establish priorities. Imagine a forest where different species stand side by side, each one contributing to the greater whole. In this dense congregation, trees often exhibit a remarkable behavior known as root grafting. This occurs when tree roots fuse together, allowing for the sharing of resources and genetic material. Picture a network of roots intertwining beneath the surface, forming bonds that enable trees to share nutrients and water, even across species. This phenomenon not only exemplifies cooperation but also serves as a lifeline during times of stress. When one tree faces adversity, such as drought or disease, those intertwined roots may allow for the transfer of essential resources, fostering resilience in the face of challenges. Such cooperative behaviors are not limited to resource sharing. Trees also engage in vocalizing their needs through a variety of chemical signals that travel through the air and soil. When trees release distress signals, they initiate a communal response. Imagine a grove of trees responding in unison to the scent of a chemical signal that indicates an imminent threat. Nearby trees prepare their defenses, ramping up their production of protective compounds before any harm can reach them. This anticipatory cooperation transforms the forest into a living organism, where each tree's fate is intertwined with that of its neighbors. The mutual aid among trees extends to their offspring, as established trees often prioritize the well-being of their young. This nurturing behavior manifests in the way parent trees provide shade and nourishment to saplings. Picture a young tree striving to reach the sunlight, sheltered and supported by the sprawling branches of its parent. Such acts of kindness are not solely instinctual. They are imbued with an understanding of the importance of lineage and the continued thriving of the forest. This prioritization of kinship is a reflection of an evolutionary strategy that underscores the importance of relatedness in the tree community. It draws our attention to a natural question. Why do trees prioritize communication and cooperation with related species? The answer lies in the survival of their shared genetic legacy. By fostering a supportive environment for their kin, trees enhance the chances of their genetic material continuing through the generations, ensuring the survival of their lineage amidst the ever-changing tapestry of life. In the interplay of cooperation and competition, we also witness remarkable adaptations that arise from the struggle for light. Trees have developed various strategies to optimize their growth in the race for sunlight. Some species may grow taller, reaching upwards to outstrip their neighbors, while others may adopt a more conservative approach, remaining shorter yet sturdier, capable of thriving in shaded conditions. This diversity of strategies reflects the adaptability of trees within their ecosystems, where both competition and cooperation shape their evolution. Consider the majestic redwoods, towering high above the forest floor, basking in the sunlight. Their sheer height is a testament to the competitive nature of tree growth. Yet beneath their lofty crowns lies a network of roots that often graft with others, forming connections that allow for mutual support. In contrast, species such as the understory tree, the dogwood, flourish in the dappled light, showcasing a different strategy altogether. These trees thrive in the shadows, where they engage in cooperative interactions with the larger canopy above, benefiting from the shade while still accessing necessary resources. As we explore further, we come to appreciate the intricate relationships that trees maintain, not only with one another, but also with the myriad of organisms that inhabit their spaces. Trees serve as vital hubs within their ecosystems, providing shelter, food, and sustenance to countless creatures, from the smallest insects to the grandest mammals. This interdependence highlights the harmonious balance of life within the forest, where trees act as both competitors and caregivers. The forest's complexity deepens as we consider the role of pollinators and seed dispersers, whose lives are intricately woven into the fabric of tree communities. Trees often rely on specific species of birds and insects to facilitate reproduction, ensuring that their seeds are spread far and wide. Imagine the vibrant colors of flowers blooming in the spring, attracting bees and hummingbirds, who, in exchange for nectar, assist in the pollination process. This beautiful symbiosis illustrates how trees extend their influence beyond their immediate surroundings, fostering connections that enhance the richness of the ecosystem. In this grand network, trees have an extraordinary ability to communicate not just with one another, but with the very soil that nurtures them. They send chemical signals through their roots, releasing compounds that can influence the microbial communities in the surrounding soil. This interaction underscores the importance of nurturing the health of the soil, as the vitality of trees is deeply intertwined with the life beneath their roots. Imagine the bustling world of soil microorganisms, responding to the cues from tree roots, enriching the soil and creating a thriving environment that sustains the forest. As the sun sets, casting long shadows across the forest floor, we are reminded of the delicate balance that sustains this vibrant ecosystem. The trees stand tall, guardians of the forest, each one a participant in a grand narrative of cooperation and competition. This intricate web of relationships has evolved over millennia, teaching us valuable lessons about the power of connection, resilience, and the intricate dance of life that unfolds within the world around us. In our journey through the forest, we witness the profound wisdom of trees as they navigate their lives, embodying both the strength of competition and the grace of cooperation. Their stories are a testament to the beauty of life itself, encouraging us to reflect on our own connections and the importance of nurturing the bonds we share with one another and the world around us. Chapter 6. Alarm signals, warning neighbors of threats. In the dense embrace of the forest, an unseen symphony plays out, where trees not only communicate but also issue alarm signals to one another. The mechanisms of alarm signaling in trees are both intricate and deeply fascinating. When a tree senses danger, be it from an invasive pest or a disease, it releases specific chemical compounds into the air. These compounds act as a clamor of warnings, echoing through the forest and urging its neighbors to prepare for the impending threat. Picture a sentinel tree, its bark rough and weathered, suddenly exhaling a cloud of volatile organic compounds. This release is not a solitary act. It reverberates through the stillness of the woods, a clarion call that travels far beyond its origin. Imagine the moment a tree releases these alarm signals. What happens next? Nearby trees tuned into this forest communication network detect the increase in volatile compounds. They respond not just passively, but actively, ramping up their own defenses. This remarkable response can manifest in various ways: enhanced production of protective chemicals, a thickening of leaves, or even the closing of stomata to prevent further invasion. In essence, the entire community mobilizes, a testament to their interconnectedness and shared fate. The case studies of trees warning each other about pests provide concrete examples of this extraordinary behavior. One famous instance involves the acacia tree and its neighboring flora. When acacia trees are attacked by herbivorous insects, they emit a barrage of chemical signals that can be detected by nearby acacias. These neighboring trees, upon receiving the alarm, begin to produce tannins, bitter compounds that deter the very pests threatening their kin. This defensive mechanism not only showcases the acacia's ability to communicate, but highlights the forest's collective resilience. Consider the majestic Douglas fir, another remarkable case. When these trees face an onslaught from bark beetles, they release pheromones that alert other firs to the danger. The neighboring trees respond with a surge in resin production, a sticky lifeblood that can trap and suffocate the invasive beetles. This chemical dialogue is a powerful reminder of the cooperative spirit alive in the forest, where each tree stands as both an individual and a member of a greater community. The implications of alarm signals for forest ecosystems are profound. When trees warn each other, they create a dynamic ecosystem that is more resilient to threats. This collective awareness allows forests to fend off pests more effectively, reducing the likelihood of widespread damage. The rich interactions among tree species and their ability to share distress signals enhance biodiversity, as healthy trees support a plethora of life forms. Additionally, these alarm signals play a critical role in nutrient cycling within the forest. When trees alert their neighbors, it can trigger a chain reaction that influences the entire ecosystem. Increased resin production not only serves to deter pests, but also can attract beneficial insects that prey on the invaders. In this way, the forest becomes a living organism, where one tree's distress can lead to the flourishing of myriad other life forms. Beyond the immediate responses, these alarm signals also have long-term consequences for forest dynamics. When trees communicate threats, it enables them to adapt and evolve over generations. Forests with a rich tapestry of signaling mechanisms often exhibit greater health and stability. This resilience is reflected in the diversity of species present, as trees that work together can create niches and habitats for a variety of organisms. Consider the words of botanist David Attenborough, who once stated, "The natural world is changing, and we are totally dependent on that world. It provides our food, water, and air." In understanding the alarm signals among trees, we deepen our appreciation of this dependency. The forest is not merely a collection of individual organisms. It is a complex web of life, where cooperation and communication are essential for survival. The ability of trees to warn their neighbors is a poignant reminder of the interconnected nature of life on Earth. As we explore these alarm signals, it becomes clear that they are not just rudimentary responses. They are sophisticated adaptations that have evolved over millennia. The capacity for trees to communicate threats reflects a deep-rooted intelligence that belies their stationary existence. Imagine standing in a forest, surrounded by towering trees, each one equipped with its own method of signaling. The air thickens with the essence of life, where each rustle of leaves might carry with it a warning or a plea for solidarity. The world of tree communication is a testament to the resilience of nature. The next time you stroll through a forest, take a moment to reflect on the unseen interactions happening around you. Each tree, with its unique history and experience, contributes to the health of the entire ecosystem. They stand not as solitary giants, but as vigilant guardians of their realm, always ready to sound the alarm. The narrative of alarm signaling in trees paints a vivid picture of life beneath the canopy. It invites us to consider the complexities of existence, where every rustle and whisper tells a story of survival, cooperation, and the delicate balance of life. As we move forward, let us carry with us the understanding that this communication is not merely functional. It is a reflection of the profound connections that bind us all to the natural world. In the grand tapestry of the forest, alarm signals serve as vital threads, weaving together the stories of countless species, all intertwined in a dance of life. The next chapter of our exploration will take us deeper into the heart of these connections, illuminating the ways in which trees and their ecosystems thrive together in harmony. As we trace the intricate pathways of alarm signaling, we uncover further layers of complexity in the forest's communication network. Beyond the immediate responses of neighboring trees, the forest itself operates as a living entity, with alarm signals shaping not only individual trees, but the entire ecosystem. This interconnectedness is vital for the health and resilience of the forest. Consider how alarm signals can influence the behavior of various species within the forest. When a tree releases volatile organic compounds, these chemicals can attract not just neighboring trees, but also a myriad of other organisms. For instance, when certain trees signal distress due to pest infestations, these same signals may lure predatory insects that thrive on the pests, threatening the trees. This ecological interplay creates a dynamic where trees are not merely passive defenders. They actively engage with the surrounding fauna, promoting a balanced ecosystem. In one remarkable study, researchers observed the effects of these signals in an oak forest. When oaks were attacked by caterpillars, they emitted specific compounds that attracted parasitic wasps. These wasps, in turn, laid their eggs in the caterpillars, effectively eliminating the threat to the oaks. This mutual reliance illustrates the profound connections among species, where the alarm signals of one tree can trigger a cascade of beneficial actions throughout the ecosystem. Imagine wandering through this forest, where the air is alive with the scent of pine and the rustle of leaves. Each inhalation carries a story, a blend of signals exchanged between trees and the myriad creatures that inhabit their branches. The enchanting aroma of the forest is not only pleasing, but serves as a reminder of the interconnectedness of life. The implications of these alarm signals extend to the forest's overall biodiversity. Forests that have a rich network of communication are often more resilient to pests and diseases, allowing them to thrive even amidst environmental changes. The ability of trees to warn each other and adapt collectively fosters a vibrant ecosystem where various species coexist harmoniously. Renowned ecologist Peter Wohlleben, in his exploration of tree communication, eloquently remarked, "Forests are like a community of people, where everyone knows each other and helps one another." This observation resonates deeply, as it highlights the essence of cooperation that is essential for survival in the wild. The forest, much like a community, thrives on its ability to communicate and act in unison, fostering a sense of belonging and shared responsibility among its inhabitants. Moreover, alarm signals can influence the genetic evolution of trees. When certain trees develop effective defense mechanisms in response to threats, these adaptations can be passed down through generations. Over time, this can lead to a population of trees that are more adept at surviving in their environments. Imagine standing among ancient trees, each one a testament to the resilience of its lineage, equipped with the wisdom of its predecessors. Consider the resilience of the redwood trees, which have adapted to withstand both fire and pest damage. When one redwood signals distress, it may prompt neighboring trees to bolster their defenses, forming a protective barrier against potential threats. This mutual aid not only ensures the survival of individual trees but contributes to the longevity of the entire forest. As we contemplate the mechanisms of alarm signaling in trees, it becomes apparent that these interactions are vital for the forest's health. The ability of trees to communicate alarms fosters a symbiotic relationship that extends beyond mere survival. It nurtures a thriving ecosystem rich in diversity, where the strength of one tree is intertwined with the well-being of others. In exploring these case studies, we find an inspiring testament to the resilience of forests. Each alarm signal serves as a reminder of the delicate balance within the ecosystem and the importance of cooperation in the face of adversity. The stories of acacia trees and Douglas firs are but a glimpse into the larger narrative of life in the forest, where alarm signals forge connections that echo through time. As we dwell on these implications, let us also consider how human activity impacts these intricate networks. Urbanization, deforestation, and climate change pose significant threats to the delicate balance of forest ecosystems. The interruption of these alarm signaling pathways can have cascading effects, weakening not just individual trees but the entire community. Imagine the silence that descends when a forest is stripped of its trees, the vibrant communication stilled. This loss reverberates through the ecosystem, as the absence of alarm signals leaves neighboring trees vulnerable to threats. It prompts us to reflect on our role in safeguarding these vital networks. The understanding of alarm signaling among trees invites us to appreciate the profound relationships that exist within the natural world. As stewards of the environment, we hold the responsibility to protect and preserve these ecosystems, ensuring that the symphony of life continues to thrive. In this interconnected web of life, each tree, each signal, contributes to the rich narrative of the forest. The alarm signals of trees remind us of the delicate balance that sustains life, urging us to listen closely to the whispers of the woods and to recognize our place within this intricate tapestry. As we continue our journey through the forest, we will uncover deeper layers of connection, exploring how these alarm signals pave the way for resilience and cooperation in the face of challenges. The heart of the forest beats steadily, a reminder of the enduring power of communication and community. Chapter 7. The impact of environmental factors on tree communication. Light, water, and soil conditions serve as the very foundation upon which trees build their communication networks. Each of these factors influences not only the growth of trees, but also how they interact with one another and their environment. Imagine, if you will, the gentle rays of sunlight filtering through the canopy, casting a mosaic of light and shadow on the forest floor. This light is not merely a source of energy. It is a vital cue that affects how trees communicate. Trees utilize light to gauge their surroundings and determine their own health status. When sunlight is abundant, trees can produce energy through photosynthesis, generating carbohydrates that fuel their growth and, importantly, their communication mechanisms. Consider a situation where one tree finds itself overshadowed by its taller neighbors. It may respond by stretching its branches upward, reaching for the light. In this pursuit, the tree might release chemicals that signal its distress. These signals can inform nearby trees of their own positioning and health. The interplay between light and chemical signaling becomes a delicate negotiation, with each tree adjusting its behavior in response to both the light available and the signals it receives from its neighbors. Water, too, plays a critical role in this intricate communication network. Beneath the surface, roots intertwine with one another, and with the fungal networks that connect them. The quest for water often leads to competition, yet it also fosters cooperation. Imagine the roots of two trees, each drawing moisture from the same soil. Through their extensive root systems, they can share information about water availability. If one tree detects a richer source of water, it can send signals to its neighbor, effectively saying, "Come this way, there is enough for us both." The sharing of resources is vital, especially during times of drought when every drop counts. Soil conditions, encompassing its nutrient content, pH, and structure, also significantly influence tree communication. Healthy soil teems with life, providing not only nutrients but also a medium for chemical exchanges. When trees sense that their soil is becoming depleted, they can alter their root exudates, the substances released into the soil, to attract beneficial microorganisms that enhance nutrient availability. This interaction showcases a remarkable adaptability, reminding us of the interdependence of life beneath the surface. As we shift our gaze outward, we cannot ignore the looming specter of climate change and its profound impact on tree communication networks. The changing climate alters temperature patterns, precipitation levels, and even the frequency of natural disturbances. Trees are not static beings. They respond dynamically to these shifts. Imagine a forest that once thrived in a temperate climate, now facing prolonged droughts and increased temperatures. The communication strategies of trees in such environments undergo significant transformation. Trees adapt to these changes through various strategies. For instance, they may alter their chemical signaling. Research indicates that trees experiencing stress due to climate change may emit different volatile organic compounds, signaling their distress in new ways. This adaptation to an evolving environment can create a ripple effect, influencing not just the individual tree, but the entire forest community. It raises the question, how does a tree decide which signals to send in a world that is constantly changing? The answer lies in the intricate feedback loops formed through their extensive communication networks. Furthermore, as climate change leads to increased pest infestations and diseases, trees may enhance their defensive mechanisms. This could involve ramping up the production of protective compounds or fortifying their physical structures. Imagine a tree that stands tall and resolute in the face of a new threat, its bark thickening in response to the increased risk of insect attacks. This resilience is not solely an individual trait. It reflects the collective wisdom of the forest, where trees learn from one another and adjust in unison. In this context, the concept of adaptation becomes paramount. Trees possess an incredible ability to respond to environmental stressors. When faced with drought, some species may develop deeper root systems, allowing them to access moisture from deeper soil layers. Others may reduce their leaf area to minimize water loss through transpiration. These adaptations are not random. They are informed by the communication that occurs both above and below ground. Imagine standing in a forest where trees swayed gently in the breeze, each one a testament to resilience and adaptability. Here, the air is thick with the scent of leaves and earth, a reminder of the interconnectedness of life. Through their ability to communicate and adapt, trees contribute to the health of the ecosystem, ensuring not just their survival, but the survival of countless other species that rely on them. As we consider the implications of environmental factors on tree communication, we begin to appreciate the depth of their interactions. The forest is not merely a collection of trees. It is a living, breathing entity shaped by the flow of water, the warmth of sunlight, and the richness of soil. Each factor plays a role in the grand narrative of life, where trees are not silent sentinels, but vibrant participants in a complex ecological story. In this intricate dance of survival, adaptation, and communication, trees remind us of the profound links that bind all living things. They teach us that even in the face of significant environmental changes, there is hope in cooperation and resilience. As the winds whisper through the leaves, one can almost hear the stories of survival, adaptation, and the silent yet powerful conversations of the trees. In a world increasingly marked by uncertainty, the lessons learned from trees and their communication networks resonate strongly. They show us that while change is a constant, the ability to adapt, cooperate, and communicate can lead to flourishing even in the most challenging circumstances. The forest, in all its beauty and complexity, stands as a testament to the enduring connections that sustain life, reminding us that we, too, are part of the intricate web of existence, woven together by shared experiences and mutual support. As we continue to explore the remarkable world of trees, it is essential to remember that they are not simply passive participants in their environment. Instead, they are active agents, continually engaging with one another and adapting to the world around them. Their ability to communicate in response to light, water, soil conditions, and the challenges posed by climate change exemplifies a profound wisdom that has evolved over millennia. Through this lens, we gain a deeper understanding of what it means to be part of a community, where each voice matters and every connection counts. Just as trees share nutrients and signals, we too can learn from their example. The resilience of the forest offers a calming reminder that together, we can weather any storm, adapt to new realities, and thrive amidst the changes that life brings. As we reflect on the significance of these communication networks, let us carry forth the knowledge that every whisper of the leaves, every rustle in the underbrush, is a reminder of the stories that trees have to tell. They beckon us to listen, to learn, and to appreciate the intricate web of life that surrounds us, inviting us to explore the depths of their wisdom and the beauty of their world. As we consider the intricate dynamics of tree communication, the looming specter of climate change adds another layer of complexity to this already fascinating web of interactions. Rising temperatures, shifting precipitation patterns, and the increasing frequency of extreme weather events fundamentally alter the environment in which trees thrive. Imagine a once vibrant forest, now grappling with prolonged droughts, flooding, or invasive species, each posing unique challenges that reshape tree communication networks. One of the stark realities of a changing climate is the impact on tree phenology, the timing of life cycle events such as budding, flowering, and leaf drop. These seasonal rhythms are finely tuned to environmental cues, and any disruption can cascade through the forest ecosystem. For instance, if trees begin to bud earlier due to warmer temperatures, this can lead to mismatches with the species that rely on them for food and habitat. In this altered landscape, how do trees adapt their communication strategies to ensure their survival? Some trees have evolved remarkable resilience strategies. For example, in response to increased drought conditions, trees may enhance their root systems, extending them deeper into the soil to access moisture. This adaptation is not merely physical. It influences their communication as well. Imagine the roots of a drought-stressed tree sending out signals to neighboring trees, sharing information about water availability, and encouraging them to do the same. This collective action underscores the forest's shared commitment to survival, where resilience is rooted in cooperation. Furthermore, trees are not passive recipients of change. They actively engage with their environment through their chemical signaling. In response to stressors like drought, trees may alter their volatile organic compound emissions, adapting their chemical language to reflect their health and needs. This ongoing dialogue not only informs neighboring trees of their condition, but also allows them to adjust their own responses. The forest becomes a dynamic chorus, each tree contributing to a symphony of survival. The influence of climate change also extends to forest pests and diseases, which are on the rise as temperatures warm and environments shift. In response, trees may ramp up their defenses, producing more secondary metabolites, compounds that deter herbivores or inhibit the growth of pathogens. This adaptation highlights the interconnectedness of tree communication networks, as trees learn and respond not just to their immediate environment, but also to the pressures exerted by a changing climate. Consider the story of the eastern hemlock, a tree species that has faced significant threats from an invasive insect, the hemlock woolly adelgid. As these pests infiltrate forests, hemlocks have been observed to emit stress signals that not only alert neighboring trees to the impending threat, but also attract natural predators of the adelgid. This behavior illustrates a remarkable strategy of adaptation, where communication transcends individual survival and fosters a communal response to external threats. Imagine standing in a forest that is adapting in real time to these environmental changes, where the air is filled with the mingling sense of resilience and renewal. Here, trees are not simply reacting to the immediate challenges, but are engaged in a constant process of learning and evolution. Each signal exchanged, Each root connection made serves as a testament to their ability to thrive amidst uncertainty. In this evolving narrative, adaptation strategies take on a multifaceted nature. Not only do trees respond to immediate threats, but they also prepare for future challenges. For example, some species may exhibit phenotypic plasticity, altering their growth patterns or leaf structures in anticipation of changing conditions. This proactive approach exemplifies a tree's remarkable capacity to not only endure, but to thrive in a world marked by unpredictability. As we delve deeper into the heart of these adaptations, we begin to understand that trees are not isolated beings, but interconnected participants in a broader ecological narrative. Their communication is a vital thread in the fabric of the forest, woven through relationships that foster resilience and cooperation. This understanding urges us to reflect on our own connections to nature and the ways in which we too might adapt and communicate in the face of change. The forest teaches us that adaptation is not a solitary endeavor. Just as trees share information and resources, we too can learn from their example. In times marked by uncertainty, the lessons of resilience and cooperation resonate deeply. The ability to communicate effectively, to listen and respond to one another, can foster a sense of community that transcends individual challenges. As we stand amidst these towering sentinels, we cannot help but feel a sense of calm wash over us. The gentle rustle of leaves, the soft creaking of branches, all serve as reminders of the intricate web of life that surrounds us. Here, in this serene environment, we are invited to listen to the whispers of the trees, to the silent conversations unfolding beneath the soil, and to the shared wisdom that flows through the forest like a gentle stream. In contemplating the impact of environmental factors on tree communication, we are reminded of the profound interconnectedness that characterizes our world. Trees, in their silent yet powerful ways, offer us insights into the importance of adapting, cooperating, and communicating in the face of change. Their resilience serves as a guiding light, illuminating a path forward as we navigate the complexities of our own lives amidst a rapidly changing environment. Let us carry with us the knowledge that, like trees, we too possess the capacity to adapt, to grow, and to thrive together. The forest stands as a testament to this truth, a living reminder of the beauty and strength found in connection, communication, and the shared journey toward resilience. Chapter 8. The Effects of Human Activity on Tree Communication. The lush expanse of the forest, once a harmonious sanctuary, begins to experience the reverberations of human activity, fundamentally altering the communication pathways that trees have painstakingly established over centuries. Deforestation stands as one of the most impactful consequences of our relentless pursuit of progress. With each tree felled, an intricate network of roots and fungal connections is severed, dismantling the symbiotic relationships that have sustained the forest's ecosystem. Imagine the profound silence that follows the sudden removal of a towering oak, a tree that had stood for generations, whispering secrets to its neighbors through chemical signals and root exchanges. The loss is not merely of the tree itself, but of the entire web of communication that had thrived around it. As trees are cut down, the remaining ones are often left isolated, stripped of their community support. This isolation can disrupt their ability to signal distress or share resources effectively. It is as if a vital thread of conversation has been abruptly silenced. Each tree, once part of a collective, is now forced to fend for itself, grappling with the challenges of survival without the cooperative exchange that is essential for resilience. This echoes the sentiment of renowned ecologist Suzanne Simard, who emphasized the importance of these networks by stating, "The trees are communicating, and they are doing it in ways that we can't see." The disruption of these networks due to deforestation poses a significant threat not only to the trees themselves, but to the myriad life forms that depend on them. Urbanization brings forth another layer of complexity in the story of tree communication. As cities expand and the landscape is reshaped to accommodate human needs, the fragmentation of tree populations becomes inevitable. Picture a sprawling metropolis, where concrete and steel replace the soft embrace of greenery. In this environment, trees are often planted in isolation, devoid of the rich networks that once connected them to their kin. Urban trees face a unique set of challenges, from restricted root growth to pollution, and their ability to communicate with one another is severely hampered. Without the support of neighboring trees, they struggle to share nutrients and fend off threats, becoming vulnerable in an unyielding landscape. Fragmentation not only affects the physical space trees inhabit, but also their very essence. The rich exchange of information that occurs in a thriving forest community is diminished, leading to weakened defenses against pests and diseases. Trees that might have once rallied together in the face of adversity are now solitary sentinels, attempting to navigate the challenges of their environment alone. This raises an important question. What happens to the resilience of a tree when it is cut off from its community? The answer lies in the very nature of their communication networks. Without the reinforcement of shared resources and information, the chances of survival diminish, echoing through the ecosystem. Yet, amid the challenges posed by human activity, hopeful initiatives are emerging. Conservation efforts are taking root, aiming to protect and restore tree communication pathways. Imagine a dedicated team of ecologists and volunteers working tirelessly to replant native species in deforested areas, recreating the intricate networks that once thrived there. These efforts are not merely about planting trees. They are about rekindling the connections that sustain life in the forest. By fostering biodiversity and reestablishing mycorrhizal networks, conservationists are striving to create conditions where trees can once again communicate effectively. Innovative approaches, such as creating wildlife corridors, seek to reconnect fragmented habitats, allowing trees and other organisms to thrive in a harmonious environment. These corridors act as lifelines, bridging gaps created by urban development, and offering pathways for trees to communicate and share resources. They serve as a reminder that, even in the face of adversity, nature has an incredible capacity for resilience and recovery. As we consider the future of tree communication, it is essential to recognize the value of preserving these pathways. Imagine a forest where trees stand shoulder to shoulder, their roots intertwined, fostering a vibrant community that works together to thrive. The beauty of this interconnectedness is not just a spectacle for the eyes, but a vital component of ecological health. The journey towards restoring these networks is not simple, but it is a path worth pursuing. Conservation efforts remind us of the profound relationships that exist in nature and the importance of protecting them. In doing so, we not only safeguard the trees, but also the intricate web of life that depends on their existence. The challenge lies in understanding the depths of these relationships and the subtle yet powerful ways in which trees communicate. As we move forward, let us embrace the lessons learned from the intricate communication systems of trees. The impacts of human activity, while significant, also present opportunities for change. By fostering a deeper understanding of how trees interact and supporting conservation initiatives, we can play a role in restoring the delicate balance of ecosystems that have thrived for millennia. What will the future hold for our forests? With a commitment to preservation and an appreciation for the complex web of communication that binds trees together, we can nurture a landscape where these magnificent beings flourish once more. The echoes of tree communication will continue to resonate, a testament to the resilience of nature and the interconnectedness of all living things. As we turn our attention to the pressing issue of deforestation, the consequences of our actions become increasingly evident. Forests, teeming with life and vibrant communication, are being stripped away at an alarming rate. The intricate networks of trees, once thriving and resilient, are now fragile and compromised. The act of cutting down trees, not only removes the giants that provide shade and habitat, but also disrupts the delicate balance of life that exists within these ecosystems. Consider the vast interconnected web beneath the surface, where roots and fungi once flourished in symbiosis. With each tree removed, the threads of this web are frayed, and the community of trees is diminished. The loss of even a single tree can send ripples through the ecosystem, altering the dynamics of nutrient exchange and communication. Trees that were once able to share resources and warn one another of threats are now left isolated, struggling to survive in a fragmented environment. The impact of urbanization further exacerbates this issue. As cities expand, green spaces are often sacrificed, leading to a disconnection between trees and their natural habitats. Imagine a bustling city where concrete and asphalt dominate, and the few remaining trees stand alone, their roots severed from the rich networks that once sustained them. In such environments, the ability of trees to communicate and cooperate is severely limited. The isolation experienced by urban trees is striking, as they face challenges not only from limited space but also from pollution and competition for resources. Their ability to thrive is compromised, and their once vibrant communication networks become mere echoes of their former selves. As we examine the challenges faced by urban trees, we must also consider the solutions being implemented to counteract these effects. Innovative urban forestry initiatives are emerging, focusing on integrating trees into city planning and promoting biodiversity. Picture a cityscape transformed by the presence of trees, where green roofs and vertical gardens flourish alongside high-rises. Such initiatives aim to create environments where trees can communicate and support one another, even in the midst of urban chaos. By planting native species and fostering green corridors, urban planners are beginning to reinstate the connections that were lost. These corridors serve as vital passageways, allowing trees and other organisms to thrive and interact. Within these green spaces, trees can once again engage in the rich dialogue that is essential for their health and resilience. They can share nutrients, alert one another to threats, and create a vibrant tapestry of life that benefits not only the trees themselves, but the urban community at large. The importance of conservation efforts cannot be overstated. Organizations dedicated to reforestation are working to restore the vital communication pathways that have been disrupted by human activity. Imagine a reforested area where saplings are carefully nurtured, their roots reaching out to form new bonds with the surrounding soil and fungi. In these efforts, the aim is not only to plant trees but to re-establish the intricate networks that are essential for their survival. Ecologists and volunteers alike recognize that when trees are planted in clusters, they have the opportunity to create relationships that mirror those of mature forests. By clustering trees together, they can once again engage in the exchange of resources and information, fostering a sense of community that is critical for their survival. This is a testament to the resilience of nature. Even in the wake of destruction, the potential for recovery exists if we take the right steps. Imagine walking through a newly restored forest, where the air is filled with the scents of pine and damp earth. The trees stand tall, their trunks intertwined with the delicate networks of mycorrhizal fungi below. Here, the communication pathways are being rebuilt, allowing for the exchange of nutrients and signals once more. The forest is alive with whispers, a symphony of life that echoes through the trees, a reminder that even after disruption, healing is possible. To further aid in this recovery, researchers are exploring the role of technology in conservation efforts. Imagine drones equipped with seed dispersal mechanisms, scattering native seeds across deforested landscapes, creating new opportunities for growth and communication. These technological advancements offer hope for restoring ecosystems that have been damaged, allowing nature to reclaim its space and re-establish vital connections. As we ponder the future of tree communication, we are reminded of the profound impact our actions have on these majestic beings. The fate of forests lies in our hands, and with conscious efforts, we can create a future where trees once again thrive in interconnected communities. By prioritizing conservation and embracing innovative solutions, we can help to restore the delicate balance that sustains not only trees, but the myriad forms of life that depend on them. What will it take for us to recognize the value of these relationships? The answer lies in our willingness to listen. To the rustling leaves, the swaying branches, and the silent conversations happening beneath our feet. By fostering an appreciation for the complex communication systems of trees, we can begin to understand our role in protecting these vital ecosystems. With dedication and foresight, we can ensure that the stories told by trees continue to resonate through the ages, a testament to the enduring power of nature and the connections that bind us all. In this endeavor, each of us can play a role in nurturing the forests, whether by planting a tree, supporting conservation initiatives, or simply learning to appreciate the beauty and complexity of the natural world. The journey toward healing and restoration may be long, but it is a path worth traversing, one that can lead us to a future where trees flourish and communicate freely once more. Chapter 9. The Science Behind Tree Communication Research. In the ever-evolving field of tree communication research, scientists are employing a variety of methodologies to unveil the secrets held within the forest. These approaches are as diverse as the trees themselves, allowing researchers to uncover the rich tapestry of interactions that take place beneath the forest canopy. One of the most significant methods involves the use of advanced imaging technologies. Techniques such as infrared thermography and ground-penetrating radar enable scientists to visualize root systems and their interactions with both neighboring trees and the soil. Imagine a landscape where the hidden networks of roots are illuminated, revealing the intricate connections that thrive below the surface. Additionally, the utilization of molecular techniques has opened up new avenues for understanding chemical signaling among trees. By analyzing the volatile organic compounds released by trees in response to stress or environmental changes, researchers can gain insight into how trees communicate their needs and convey warnings. This chemical dialogue is further explored through gas chromatography mass spectrometry, allowing scientists to identify specific compounds and their effects on nearby flora. As trees engage in this silent conversation, they not only protect themselves but also foster resilience within their communities. Field experiments play a crucial role in advancing tree communication research. By manipulating environmental variables, such as soil nutrients or moisture levels, scientists can observe how trees adjust their communication strategies in response to changing conditions. These experiments shed light on the dynamic nature of tree interactions, illustrating how they adapt their signals based on the challenges they face. For instance, consider a grove of trees experiencing drought. In this scenario, researchers may find that trees increase the release of specific chemicals to signal distress, prompting their neighbors to adjust their own water usage accordingly. One notable breakthrough in the study of tree communication emerged from the work of Suzanne Simard, a pioneering ecologist known for her research on mycorrhizal networks. Simard's studies revealed that trees not only communicate through their roots, but also through fungal networks, exchanging nutrients and information in a manner akin to a vast social network. Her findings have reshaped our understanding of forest ecosystems, highlighting the importance of cooperation among trees. The trees are not individuals, but part of a much larger community, Simard has emphasized, capturing the essence of interconnectedness in the forest. As we delve into recent discoveries, it becomes evident that trees have developed remarkable strategies for resilience. Research has shown that trees can share resources such as water and nutrients through their root systems, often prioritizing the needs of neighboring trees that are struggling. This altruistic behavior suggests a complex social structure, one where trees recognize and respond to the needs of their companions. Imagine the quiet strength of a tree, choosing to allocate its resources not just for personal survival, but for the vitality of the entire grove. Another breakthrough involves the understanding of alarm signaling. where trees emit chemical compounds in response to threats. Recent studies have demonstrated that when one tree is under attack, it can signal neighboring trees to bolster their defenses, effectively mobilizing the entire community against potential dangers. This communal response showcases the remarkable ability of trees to work together, reinforcing the idea that a forest is not merely a collection of individual organisms, but a cohesive community. Looking towards the future, the potential for tree communication research is vast and multifaceted. As scientists continue to refine their methods, new technologies will likely emerge that provide even deeper insights into the interactions that define forest ecosystems. One promising direction involves the integration of artificial intelligence and machine learning to analyze large datasets generated by tree communication studies. Such advancements could enable researchers to identify patterns and correlations that may have previously gone unnoticed. The exploration of tree interactions in urban environments is another area ripe for investigation. As cities expand and green spaces become fragmented, understanding how trees communicate in these altered landscapes will be essential. Urban forests face unique challenges, yet they also present opportunities for resilience and adaptation. Imagine a city park where trees must navigate the stresses of pollution, drought, and isolation. Research in this area could illuminate how urban trees adapt their communication strategies to thrive amidst these pressures. Moreover, the effects of climate change on tree communication are becoming an increasingly pressing concern. As temperatures rise and weather patterns shift, trees may need to adjust their signaling mechanisms to cope with new environmental stresses. Future studies could investigate how these changes impact the social dynamics of tree communities, providing crucial insights into forest resilience in the face of a changing climate. In this intricate dance of life, the future of tree communication research holds the promise of revealing not just the mechanisms behind these interactions, but also the profound implications they have for ecosystem health and sustainability. As we continue to explore the depths of this silent symphony, we are reminded of the wisdom inherent in nature's design, urging us to remain attuned to the whispers that resonate within the heart of the forest. The journey of discovery is far from complete, and as researchers delve deeper into the realms of tree communication, they will undoubtedly encounter new questions that challenge our understanding. How do trees adapt their communication in response to the myriad of stresses they face? What new networks of interaction will emerge as we uncover more about these remarkable organisms? The answers lie waiting in the shadows of the canopy, beckoning us to listen closely to the stories that unfold with each rustle of leaves and each whisper of the wind. As we immerse ourselves in this captivating field, we find ourselves not just as observers, but as participants in a larger narrative, one that intertwines humanity with the natural world. The trees stand as sentinels, guardians of ancient wisdom, inviting us to explore the richness of their communication and to cherish the connections that bind us all together. The methodologies employed in tree communication research are continually evolving, allowing scientists to delve deeper into the complexities of these interactions. One recent approach combines traditional field studies with cutting-edge computational models. This fusion enables researchers to simulate tree interactions and predict responses to various environmental stressors. Imagine a digital forest, where each tree is a node in a vast network, and through sophisticated algorithms, scientists can visualize how changes in one part of the ecosystem ripple through the entire community. Such models could illuminate the pathways of communication, revealing how signals are transmitted across distances and how trees adapt their strategies in real time. Additionally, the advent of citizen science has opened up new avenues for data collection, engaging the public in tree communication research. Enthusiasts and volunteers contribute their observations, helping to create comprehensive databases that scientists can analyze for patterns. This grassroots involvement not only enriches the pool of knowledge, but also fosters a deeper connection between people and the natural world. When individuals take the time to document their experiences with trees, be it noting changes in leaf coloration or the effects of drought, they become part of a larger narrative, one that emphasizes the importance of trees in our lives. Key discoveries in tree communication science have illuminated the intricate relationships that exist within forest ecosystems. One significant finding is the role of tree age and species diversity in communication efficacy. Older trees, often referred to as mother trees, have been shown to play a central role in fostering community resilience. They not only possess extensive root networks, but also maintain a wealth of knowledge encoded in their chemical signals. Studies suggest that these elder trees help younger ones thrive, sharing resources and information crucial for survival. Imagine a wise elder in a community, guiding the younger generation and nurturing their growth. This dynamic enhances biodiversity, as the collective wisdom of older trees nurtures a more vibrant and resilient forest. Moreover, the concept of species diversity within tree populations has profound implications for communication. Forests rich in diverse species exhibit greater resilience to pests and diseases. When a variety of trees coexist, their differences in chemical signaling can create a more robust defense mechanism against threats. This interplay is akin to a diverse community where varied perspectives and skill sets enhance overall well-being. The lessons learned from these ecosystems could serve as a blueprint for sustainable forest management practices, emphasizing the need to preserve biodiversity to support healthy communication networks among trees. As researchers continue to push the boundaries of our understanding, they are also beginning to investigate the emotional aspects of tree communication. Some studies suggest that trees may exhibit behaviors akin to empathy, responding to the distress of their neighbors not just through chemical signals, but also through subtle shifts in their own growth patterns. This raises intriguing questions about the emotional lives of trees. Can we truly consider them sentient beings, capable of sensing and responding to the well-being of others? Such inquiries challenge the very core of how we perceive the natural world, urging us to reconsider our relationships with these magnificent organisms. Looking ahead, the future of tree communication research is poised to explore uncharted territories. One promising area involves the impact of urbanization on tree interactions. As green spaces become increasingly fragmented, understanding how trees communicate in these altered environments will be vital for urban planning and conservation efforts. Envision a bustling city where trees stand as solitary figures amidst the concrete, their communication networks disrupted. Research in this area could provide invaluable insights into how urban trees adapt their behaviors, potentially guiding efforts to create more resilient urban forests that foster both biodiversity and community well-being. Climate change presents another pressing challenge that will shape the future of tree communication studies. As temperatures rise and precipitation patterns become erratic, trees will undoubtedly need to adjust their communication strategies to cope with these changes. Future research could focus on how specific species respond to varying climate conditions, revealing shifts in their signaling mechanisms and interactions. Imagine a forest adapting to a warmer world, where trees develop new ways to convey information about water scarcity or increased pest pressures. Understanding these adaptations will be crucial for informing conservation strategies and ensuring the survival of forests in the face of climate adversity. In exploring these future directions, we are reminded of the interconnectedness of all life forms. The lessons learned from tree communication research extend beyond the forest, inviting us to reflect on our own interactions with the environment and with one another. As we glean insights from the wisdom of trees, we are challenged to foster a deeper understanding of our role in the ecosystem. The silent conversations that unfold among trees serve as a powerful reminder that communication is not merely a human construct, but a fundamental aspect of life itself. As the journey of discovery unfolds, each revelation brings with it a sense of wonder and a call to stewardship. The more we learn about how trees communicate, the more we understand the delicate balance that sustains our planet. In this quest for knowledge, we find ourselves woven into the very fabric of nature, inspired to cultivate a harmonious relationship with the world around us. Each tree, each root, each chemical signal forms a part of a grand narrative, one that beckons us to listen, to learn, and ultimately to protect the vital connections that bind us all. Chapter 10. Implications for Forest Management and Conservation. In the vast expanse of the forest, where sunlight dances gently upon the leaves and the air is infused with earthy aromas, understanding tree communication emerges as essential for effective forestry practices. For far too long, humans have viewed trees as solitary entities, often overlooking the intricate web of relationships that defines their existence. As we deepen our awareness of how trees interact, through chemical signals, root networks, and their symbiotic relationships with fungi, we gain insight into their needs and responses. This knowledge is not just fascinating, it is crucial for developing sustainable forest management strategies that honor the interconnectedness of life within these ecosystems. Imagine a forest where every tree is a participant in a grand conversation, exchanging vital information that influences not only individual survival but also the health of the entire community. By recognizing the significance of tree communication, foresters and conservationists can approach forest management with a renewed perspective, one that aligns with the natural rhythms and relationships that sustain these ecosystems. The health of a forest does not rest solely on the number of trees or the volume of timber harvested. It hinges on the symbiosis between trees, their ability to communicate, and the resilience fostered through cooperative interactions. Effective, sustainable forest management hinges on implementing strategies that reflect the complex interactions among trees. As we learned from the mechanisms of alarm signals and chemical communication, trees are capable of alerting their neighbors to threats, allowing for communal resilience. This insight can guide forestry practices to prioritize preserving not only individual trees, but also the networks that sustain them. For instance, when planning for logging or land use changes, it is vital to consider the broader implications for tree communication systems. Efforts should focus on maintaining diverse tree populations and protecting key species that serve as vital communicators within the ecosystem. Foresters can adopt practices that enhance the natural communication pathways among trees. Thinning, for example, can be managed carefully to avoid disrupting the delicate balance of cooperation and competition. By selectively removing trees that are less vital to the communication network, foresters can bolster the health of remaining trees, allowing them to thrive and support one another. This approach not only promotes biodiversity, but also enhances the forest's overall resilience to disease, pests, and climate fluctuations. The role of tree communication extends beyond individual tree health. It is intricately linked to biodiversity and ecosystem health. When trees communicate effectively, they foster a thriving community of species, each contributing to the richness of the forest. Biodiversity is not merely an assortment of different species, it is the foundation upon which ecological stability is built. Diverse tree populations are better equipped to withstand environmental changes, as they can share resources and information through their established networks. Forests that are managed to promote diversity also encourage a wide range of understory plants, animals, and fungi, all of which contribute to the vitality of the ecosystem. As trees share nutrients and chemical signals, they help create habitats that support various forms of life. For example, certain tree species may provide shelter for birds or serve as hosts for insects, while others contribute to the soil's nutrient profile. This interplay of life forms is a testament to the interconnectedness of the forest, where each organism plays a role in the overall health of the ecosystem. Moreover, understanding the implications of tree communication can lead to more informed conservation efforts. Conservationists can utilize this knowledge to identify critical areas within a forest that require protection. By focusing on regions where communication networks are particularly rich or where specific tree species play a pivotal role, conservation strategies can enhance the resilience of entire ecosystems. Imagine a conservation plan that not only preserves tree populations but also nurtures the underlying communication systems that allow these trees to thrive. Such an approach recognizes the forest as a living entity, one that requires holistic care rather than piecemeal interventions. As humans engage with forests, the need for responsible stewardship becomes increasingly clear. Our activities, whether logging, urban development, or agriculture, can disrupt the delicate balance of tree communication, leading to unforeseen consequences for forest health. The wisdom of the forest, expressed through its trees, provides an essential guide for managing these interactions. By listening to the forest and observing the ways in which trees communicate, we can align our practices with the natural order, fostering environments where both humans and trees flourish. The implications of tree communication can extend to urban forestry as well. In cities where green spaces often become fragmented, understanding how trees interact can inform the design of urban landscapes. Planting diverse species that can communicate effectively with one another can enhance the resilience of urban forests, helping them withstand stressors such as pollution and climate change. Urban planners can learn from the intricate relationships found in natural forests, creating green spaces that mimic these networks. This approach can transform urban environments into thriving ecosystems that contribute to the well-being of both residents and the natural world. As we continue to explore the wonders of tree communication, we find ourselves at a crossroads. The knowledge we have gained about the interconnectedness of trees presents an opportunity, a chance to redefine our relationship with the forests that surround us. Understanding how trees communicate empowers us to make informed choices that honor their wisdom and the intricate relationships they maintain. Through sustainable forest management and conservation efforts that prioritize tree interactions, we can create a future where forests are not only preserved but thrive, echoing with the silent symphony of life that unfolds beneath their canopies. Beyond the immediate implications for forest management, the lessons learned from tree communication resonate with broader themes of ecological stewardship. The intricate networks that trees form mirror the connections we share with one another and the environment. Just as trees rely on their neighbors for support and resilience, humans, too, must recognize the importance of community and collaboration in addressing the challenges we face. In embracing the complexity of tree communication, we also embrace a deeper understanding of our place within the natural world. The forest invites us to participate in its rhythm, to listen to its whispers, and to act with intention and care. This relationship calls for a shift in perspective, from viewing forests as mere resources to recognizing them as living systems that require our respect and protection. As we reflect on the journey through the intricate world of tree communication, we are reminded of the words of a renowned ecologist who stated that, quote, "The best time to plant a tree was 20 years ago. The second best time is now." This sentiment serves as both a call to action and a reminder of our responsibility to future generations. By prioritizing sustainable forest management and honoring the wisdom of trees, we can ensure that the forests continue to flourish, whispering their secrets and nurturing the delicate web of life for years to come. The insight gained from understanding tree communication is not only pivotal for enhancing forest management practices, but also integral to fostering a deeper appreciation for the intricate relationships that define forest ecosystems. As we consider the strategies necessary for sustainable forest management, it becomes clear that recognizing tree interactions can lead to innovative approaches that enhance both ecological health and economic viability. Imagine a forest where trees are not merely resources to be harvested, but active participants in a vibrant community. By prioritizing the preservation of these interactions, foresters can implement practices that reflect the natural dynamics within the ecosystem. One such strategy involves creating buffer zones around critical areas of communication, such as where diverse tree species converge. These zones serve as sanctuaries, where trees can maintain their networks unhindered by external pressures. In these protected spaces, trees can thrive, sharing nutrients and alarm signals that bolster the entire ecosystem's resilience. Moreover, the introduction of agroforestry practices can serve as an effective means of promoting tree communication while providing economic benefits. By integrating tree planting with agricultural practices, farmers can create environments where trees and crops coexist, fostering a symbiotic relationship. This not only enhances soil health through the exchange of nutrients, but also allows trees to send distress signals to neighboring plants, preparing them for potential threats. By cultivating diverse agricultural landscapes, we can mirror the complexity of natural forests, creating resilient systems that protect both biodiversity and food security. The role of tree communication in sustaining biodiversity cannot be overstated. Healthy forests, rich in diverse tree species, create habitats that support myriad organisms, from the smallest fungi to the largest mammals. Each species in this web has a role to play, contributing to the overall stability of the ecosystem. When trees establish connections through their root networks and chemical signals, they also facilitate relationships with other species, such as insects and birds, which in turn contribute to pollination and seed dispersal. Envision a thriving forest, where the rustle of leaves is accompanied by the melodies of birds and the hum of insects, each playing a part in the rich symphony of life. This dynamic interplay ensures that forests remain vibrant and productive. When tree communication is disrupted, the cascading effects can lead to declines in biodiversity, destabilizing the entire ecosystem. Therefore, conservation strategies that emphasize the health of tree communication networks are essential for maintaining the intricate balance of life in the forest. Furthermore, as we consider the impact of climate change on forests, the capacity for trees to communicate becomes even more crucial. Changing environmental conditions can stress trees, making them more susceptible to pests and diseases. However, resilient forests, those that thrive through effective communication, are better equipped to adapt to these challenges. By fostering environments where trees can share information and resources, we can help them weather the storms of change, ensuring that they continue to flourish amid adversity. The legacy of pioneering ecologists and forest scientists reminds us of the profound connections found within forests. These individuals have dedicated their lives to understanding the complexities of tree communication, revealing the wisdom embedded in nature. Their work inspires a sense of stewardship that transcends mere conservation. It invites us to engage with the natural world in a way that respects and nurtures its inherent systems. As we reflect on their findings, we are reminded that our actions today will shape the forests of tomorrow. Imagine walking through a forest imbued with vitality, where the intertwining paths of trees lead to vibrant undergrowth, rich with life. In this forest, we can see the potential for a future where forest management is not just about extraction, but about collaboration between trees, species, and even people. This vision can guide us towards a new paradigm of forestry, one that harmonizes human needs with the natural world. Through continued research and a commitment to understanding tree interactions, we can create frameworks for forest management that are sustainable and adaptable. By integrating these insights into policy and practice, we lay the groundwork for a resilient future, where forests are not only preserved, but celebrated as living entities, thriving through their intricate communication systems. As we look ahead, the importance of education and awareness cannot be overlooked. Engaging communities in the wonders of tree communication can foster a deeper connection to the forests surrounding them. Workshops, guided forest walks, and educational materials can empower individuals to appreciate the delicate balance of life within these ecosystems. When people understand the significance of tree interactions, they become advocates for sustainable practices that benefit both nature and society. In this age of environmental challenges, the call to action is clear. By prioritizing tree communication in our forest management and conservation efforts, we embrace the opportunity to cultivate healthier, more resilient ecosystems. This journey requires us to listen to the whispers of the trees and the lessons they impart about cooperation, resilience, and interconnectedness. Thus, as we continue to explore the profound implications of tree communication, we embark on a path that honors the wisdom of nature. Through our collective efforts, we can ensure that forests remain vibrant sanctuaries, echoing with the whispers of trees, nurturing life in all its forms, and inspiring future generations to cherish and protect these invaluable ecosystems.